Remember, a ratio is a comparison of two numbers by division, sometimes also called rates. In technical terms, when we speak about rates, we're referring to a comparison of two quantities where they're different units of measure, and ratios are the same unit of measure. For our purposes, we're going to use them interchangeably. So remember, a simplified ratio is very similar to a simplified fraction in that there can be no common factors between the numerator and denominator. But there are a few other things that we need for simplified ratios that we don't need with simplified fractions, or they don't come into play again. So no common factors between numerator and denominator. And obviously I'm abbreviating because of space. On a test or quiz, when you turn something in, you would write everything out. The second thing is that we can only have whole numbers or integers in order for something to be simplified. The third thing is we need those two numbers because by definition rates and ratios are a comparison of two things by division. So if I'm giving you the ratio 1/5 to 45 and I ask you to simplify it, well, this is not simplified because it fails that they're both whole numbers. And remember, we can write 1/5 to 45 in words, and we can also write it, in this case, it would be like a complex ratio. So when we have complex ratios, if you need to, you can think of this as 45 over 1. That helps us because to simplify this, we're going to take 1/5 and we're going to multiply it by the reciprocal of 45, so which is 1 over 45. Because remember, this is just like your division bar. When we multiply fractions, we simply multiply our numerator and our denominator. So we have 1 times 1 and 5 times 45. Oh, I'm sorry, I did that where you couldn't see. So I'm going to come up here. Multiply our numerators, 1, and multiply our denominator, 5 times 45. So in my head, I do 5 times 50 and then subtract that 25. So as a simplified ratio, we are at 1 over 225. And sure enough, we have no common factors and we have integers. We are all set. We'll try another one. If we need to simplify the ratio of 1/2 to 1/8, I'm going to write it in with the division bar, 1/2 to 1/8. It's not simplified because these are not whole numbers. Multiply by the reciprocal. What I find is we want to simplify before multiplying. 2 and 8 have a common factor of 2. We're left with 4. So our numerator is 1 times 4, or 4, and our denominator is 1 times 1, which is 1. This is our simplified ratio. A lot of times we'll use ratios with units for things. So if we needed to use a ratio to do a conversion problem, so say I wanted to take 30 minutes and I wanted to find out how many seconds were in 30 minutes, but I wanted to do it using a ratio. So what I would have, we want to get in the habit of writing our units. So we have 30 minutes, and we're going to multiply it by the ratio that there are 60 seconds in 1 minute. The reason we can do this is because 60 seconds equals 1 minute. So really all we're doing is we're multiplying 30 minutes by a factor of 1. And anytime we multiply something by 1, we're not changing the value. But by using this ratio, we're able to factor out, just like we factor numbers, we're able to factor out our common units between the numerator and denominator. So we're left with 30 times 60 seconds. Before panicking that these are larger numbers that we like, remember that we can think of this as 3 times 10 times 6 times 10 seconds. Multiplication can be performed in any order. And this is a step that you'll probably do in your head, but I'm writing that out. 3 times 6 is 18. 10 times 10 is 100. 18 times 100 is simply 1800 seconds. So you don't have to tackle the math in a very difficult way. You're really use what you know about factors to help ease the math that you have to do. We have proportions, and a proportion is a statement that two ratios are equal. So we have a ratio A to B, and we say that it is equal to the ratio C over D. We know these are equal, like that we have a true proportion if they're equal when simplified. Again, I'm abbreviating for space. On a test or a quiz, you could write it out. We also know they're equal when our cross products are equal. Same with the abbreviation. So if I want to find out if 5 to 3, the proportion, is equivalent to 3 to 1, so this double colon means equal. To solve this, we'll say, well, 5/3. Ask ourselves, is that equal to 3 over 1? Looking at them, 5/3 is simplified, 3/1 is simplified. No, this is not a true proportion. We can solve proportions. If we have 20 to 40 and an unknown to 9, and we want to solve this, set it up into our more traditional proportion, and check to see if you can factor anything. We can only factor within each ratio because of the equal sign, but certainly 20 and 40 have a common factor of 10. So we're looking for 2/4 is equal to what over 9? We're going to cross multiply. 2 times 9 is equal to 4 times x. Again, notice I didn't do the multiplication here. I'm going to divide both sides by 4. 4's factor out here. 2 and 4 have a common factor of 2. What we're left with is 9 divided by 2. 9/2 is equal to x. 9/2, I'm going to come up here. 4.5 is equal to x, or 4 and 1/2 is equal to x. So proportions and ratios are really handy, and we're going to find that we use them all of the time when we're talking about doing any type of dosage calculation or dosage problem.